Good morning, sports fans. Unit 4 Study Guide, Algebra 1. I'm going to go through every step of every problem. Feel free to pause, rewind, fast forward, take what you need from this video. To earn a 1 on Learning Target 4.1, you'll need to look at 4 tables of data. Determine which one does not represent a function. Here's 4 tables of data. What we're looking for here is, what a function is a relationship or a rule where every input has exactly one output. So each of these has columns of inputs and outputs. Your task is to look at all the inputs and make sure that each input has exactly one output. In this case, we have the inputs of 0, 1, 2, and 3. There's no repeated inputs here. That means that each input will only have one output because we only have one data point for each. So let's look at the next one. Here we have some repeated inputs. We have 2 zeros and we have 2 ones. That doesn't necessarily mean we don't have a function. What we need to do now is look at their associated outputs. Here in this case, with an input of 0, we have an output of 10. That means every time we see a 0 in the input column, it needs to match with an output of 10. So down here we have another input of 0, and it does indeed match an input of 10. So this works, at least as far as the zeros go. Let's look at the ones. We have repeated ones. Input of 1, output of 9. So this one needs to match. Input of 1, output of 9. Okay, so this one works. This one is a function. Each input has exactly one output. Let's look at the next one. Here I'm noticing I have the same input 3 different times. That means the output for each of these ones needs to match. Well, in this case, input of 1, output of -5, and that repeats 3 times. So far, so good. That's okay. Each input does have one output. Every time I plug in 1, the output is -5. If one of these did not match, this would not represent a function. Now, don't be fooled by this. Notice here, input of 3, and it has the exact same output. That's okay. That is saying that 1 has exactly one output, it's -5. 3, the input of 3 has exactly one output. It's also -5. That's just fine. You can have the same output for different inputs. Okay, so far these 3 represent functions. Let's see why this one is the one that's not a function. We have an input of 3, 1, 2, and 3. So the 1 and 2, that's not going to give us any information. There's no repeated stuff. We're just looking at the repeated inputs here, the 3 and the 3. Here, input of 3, output of 10. That means the other input of 3 needs to have an output of 10 for this to be a function. Well, here, input of 3, output of 7. That means that this table here does not represent a function. And to really convince your teacher you understand it, circle the outputs that don't match. Like, just make this abundantly clear. Like, hey, I understand what I am doing. This 10 and this 7 is the whole reason why this one is not a function. Now, explain why your choice is not a function. You can give the definition of a function, or you can just point out like, hey, the input of 3 had 2 different outputs. So you have options here. You could say the input of 3 has 2 outputs. You could say that. Or you could go general and say every input has maybe not every input has exactly one output. So that's using the definition of what a function is. A function says that every input has exactly one output. And so in this case, we're saying not every input has exactly one output. Again, this input of 3 has an output of 10 sometimes and has an output of 7 sometimes. That's what makes it not a function. Now, notice here, it says to earn a 2 on Learning Target 4.1, you'll need to determine which does not represent a function and explain why. We did that. If you can do this on your upcoming exam, you will earn a 2 for Learning Target 4.1. Let's keep going. Let's talk about how to earn a 3 and a 4. To earn a 3 on this upcoming exam, you'll need to answer the questions above correctly and correctly describe the input and output mean from a given function, or write that function based on a given situation. Okay, so to get a 3, you have to answer all of this correct, plus either A or B. To get a 4, all of this, plus A and B. So I'm going to talk about these. I have 2 examples, and I'm hopeful that we can make sense of all this. So an ice cream shop charges $4.50 for a scoop of ice cream and $1.50 for each topping added beyond that. Okay, so $4.50 for the initial scoop and $1.50 for each additional topping. And we're going to say each additional topping here is going to be in green. Okay, what does I of 3 equals $9 say about the situation? Well, I of x represents the cost of ice cream with toppings. So we had a total cost of $9, and the ice cream had 3 toppings. So you can say ice cream with 3 toppings, because 3 is our input, costs a total of $9. And again, to be clear where all this is coming from, this $9 is this $9. This input of 3 is this input of 3. So that's what's going on. And we need to be able to interpret, like, what does the input and the output mean in a situation like this? Now, part B, write an equation I of x where x represents the number of toppings. Okay, so here is a specific equation of ice cream with 3 toppings and how much it costs. We're gonna write a generic equation with an unknown number of toppings. So our function can be I of x, meaning ice cream with x number of toppings, equals, well, our initial cost for the initial scoop of ice cream is this $4.50. So if I got 0 toppings, I'm still paying $4.50. But if I'm getting toppings, I'm paying $1.50 per topping. Well, how many toppings am I getting in this situation? I don't know. It's a mystery number, and we're going to call that x. This means that we're paying $1.50 for every topping. $1.50 times x will be the amount of money we're spending on toppings plus the initial $4.50. This is it. This is what we're looking for in this situation. We've done something very similar in a previous exam. This time it's in function notation. Last time it wasn't. Okay, this next one is assessing the exact same topic. We're just giving you 2 chances to do it. Okay, a baseball card shop is selling an unopened box of 2025 Topps Series 1 baseball for $175. So these are unopened packs of baseball cards. The shop is running a special where you can also purchase extra packs of sleeves, like protectors for the cards, for $5 per pack with the purchase of a box of cards. B of x represents the total cost of the box of cards with extra packs of sleeves. So in this scenario, a consumer is purchasing 1 box of cards and X packs of sleeves or protectors here. So what does B of 2 equals $185 say about the situation? It's saying that 1 box of cards plus 2 packs of sleeves costs the total here $185. That's it. That's the story that this is telling. At the baseball card shop, if you get 2 packs of sleeves along with your Topps Series 1 box, you are spending $185. Now, hopefully you see what's going on here. You spend $175 on the box. If you're getting 2 packs of sleeves for $5 per pack, well, that's $10 for just the sleeves. 175 plus 10 is $185. Now, we're going to write a generic equation for B of x, where x represents the number of packs of sleeves. So B of x equals, well, the initial cost, just the box of cards, is $175. And then we are adding the cost of the sleeves. So it's $5 for 1 pack of sleeves, but we don't know how many are being purchased. So we're going to say 5x. Now, you could write 5.00, like to indicate $5, but this tells the same story here. So this is all we are looking for this example here. If you understood this and can recreate this on our upcoming exam, you will earn a 4 for Learning Target 4.1. Okay, at this point in time, I'm going to keep moving on to Learning Target 4.2. Learning Target 4.2, still about functions, but now we're talking about features of graphs, so we're going to do a little bit of domain and range action here too. To earn a 1, you'll need to identify the correct domain and range from a graph, parts A and C below. Let's start there. So this graph here is called J of T. J of T represents Josh's distance from school on a run after T minutes. So Josh is going for a run. It's T minutes in length. T is here on the x-axis, time in minutes. You can see the graph goes from 0 to 40, but well, the axis does. The graph doesn't quite go to 40. And then it looks like on the y-axis here, the distance from school in miles is going up in quarter-mile increments, 0.25. So here's 1 mile, here's 2 mile, 3 miles, etc. What's the domain? The domain is the set of all of the inputs. In this case, the input is the variable t for time. So that's going to be the variable that goes in the middle. Now in this compound inequality on the left, we're writing the smallest number in the domain, and over here the biggest number of the domain. And we're saying that t can be anything in between the smallest number and the biggest number. Well, for time here, it looks like the run started at 0 minutes, because of course it did. You don't start a run 5 minutes into a run. That doesn't make any sense. And then the end point, how long that Josh ran in this case, well, that's this point here. Let's take it straight down all the way to the x-axis. Well, 35 is there. One bigger is 36. So no calculating had to take place. We're just looking at the beginning and the end of the graph in regards to how long the run was. Now, to earn a 1, we need to do the range as well. So that's part C. So I'm going to skip B and I'll come right back to it. Part C. What is the range of j of t? So range is the y value or the output. And so the variable we're going to use here is we're actually going to put the j of t, the output. The output is the distance run in miles. So at the beginning, Josh had run 0 miles. So the j of t is somewhere in between 0 and however far they ran. So we're looking at how high this point went. This is the highest point. And it looks like 4.5. So we're saying the domain, the time run is anywhere between 0 and 36 minutes. And the range, the distance run, is anywhere between 0 and 4.5 miles. There is a data point for each of those times and each of those distances on this particular graph. Okay, so I just answered B and C as well out loud, but let's put it down with words. Because to earn a 2, you'll need to identify the correct domain and range. That's what we just did. And then it says, and correctly calculate the average rate of change, A, C, and E. Okay, so I am going to do E next to indicate how to show a 2. Calculate the average rate of change, J of t, from 10 to 18 minutes. At 10 minutes, there is a data point right here. This looks like the point 10, 1. And at 18 minutes, that is going to be this point. Let's see, 20 goes right there. 2 to the left is going to be this point here. So this is 18, 2. Okay, so from 10:1 to 18:2, we could use the slope formula for this, but this has nice friendly numbers. They're all whole numbers. They're nothing bigger than 20. Let's just use rise over run. So to go from, I always work from left to right. To go from this point to this one, we have to go up 1, 2, 3, 4 boxes. So, but each box is a quarter of a mile. So we went from 1 mile to 2 miles. So we really just went up 1. So our rise over run, we went up 1. And then we're going to run this many. We went from 10 to 18, sorry. So it looks like we went 8 boxes or 8 minutes. So in our rise over run, we got 1/8, which is, that's cool. That works. That's our fraction. Explain what it means in context. Well, the rise, the up and down, is measuring the how many miles were run. So Josh ran 1 mile, and then the run portion, which is funny, coincidence here, the rise and the run, is the time in minutes. So it looks like 1 mile in 8 minutes. And that's all that this is saying. Okay, cool. To earn a 3 on this particular, on learning target 4.2, it says you'll need to correctly answer all of these parts. So let's go back and backfill. Let's explain what the domain means. Let's explain what the range is. The domain, what does it tell you about Josh's run? It says, really, Josh ran 36 minutes. And if you want to be over the top, you can say starting it's kind of overkill, at 0 minutes. So there was a time where Josh was running 0 minutes. There was a time when he was running 1 and 2 and 3 and 4 and 18.3 and whatever. Every number between 0 and 36, there was a time when Josh was running. Or in this case, he was on a run, but it looks like he stopped to tie his shoe or something. That's what the flat part of the graph indicates. What does the range tell you about Josh's run? Josh ran from 0 miles to 4.5 miles. And everywhere in between, there was a moment of time when Josh was 1 mile into the run, 2 miles into the run, 3 miles into the run, 3.8 miles into the run, 3.9634 miles into the run. You can get as weird as you want to, but every distance from 0 to 4.5 miles is covered on this graph. There, you could figure out exactly how long it took to get a certain amount of distance anywhere between 0 and 4.5 miles. Okay, if you can understand this and demonstrate this on our upcoming exam, you will earn a 3 on Learning Target 4.2. Let's talk about how to earn a 4 on this upcoming exam. It says you'll need to answer the question above correctly as well as create your own graph from a specific set of criteria provided like the example below. Okay, so I'm giving you features of a function f of x. There are 4 features. Your graph that you make up needs to meet all 4 of these features. Now, before I even start doing this, there are lots of correct ways you could do this correctly. You don't have to do it exactly like I did. As long as your graph meets these criteria, you're in a good spot. Okay, the domain is from -4 to 3. That means the smallest this graph will go is going to be, here, I'll even mark it here. You don't have to be this in depth. But the domain is at -4 all the way to +3. It's hard to see my lines here. Hopefully your paper, the lines show up a little bit better. Okay, so those dashed lines I just put in demonstrates my domain. The graph will not go to the left of this line. The graph will not go to the right of this line. These are like fences, barriers. That's what this first criteria is telling me. F of x is increasing when x is bigger than 1. So when x is bigger than 1, the graph better be moving in an upward direction. It's still going to finish here at the dashed line, but it needs to be moving upwards over here. The maximum, this occurs, let's assign some colors. The maximum occurs at -3, 5. So -3 is 1, 2, 3, and then we're going to go up 5. 1, 2, 3, 4, 5. This is the biggest point on the graph, -3, 5. That's what that tells us. The smallest point on the graph, the minimum is at 1, 0. So that's going to be this point right here, 1 to the right of the origin, and it does not go up at all. So the maximum here is our red point. The minimum here is our blue point. And all we need to do now is create some sort of graph between the 2 dashed lines where this is the biggest point, this is the smallest point, and anywhere where x is to the right, or the graph is to the right of 1, so to the right of this point here, it's got to be going up. To the left of this point, it can do all sorts of whatever you want to do as long as it goes through this point as well. So I'm going to make mine kind of simple. This is my maximum. We'll say it goes up to this, and then it goes down to this, and then it's got to be increasing on this side. Boom. That totally works. There's other ways you could have done this, but this is what made the most sense to me in this moment. Okay, this is the entirety of Learning Target 4.1 and 4.2. If you're able to understand this and demonstrate this on our upcoming exam, you will earn a 4 for both of these learning targets. Feel free to ask your teacher further questions. Best of luck. I believe in you.